In today's video I'm going to be talking about a malaria case study. The example I'm going to be using is Ethiopia, and in this video I'm going to be looking at the environmental and human causes of that disease, and those are the spec points on the OCR A-level geography spec that I'm going to be covering. So the background of malaria is that it's a vector-borne disease which is carried and passed on by mosquitoes. They carry a parasite which they then pass on to humans by biting them, and if that parasite gets into a human and causes malaria, then that disease can actually cause death if it has left untreated. In terms of the worldwide problem, the World Health Organization say that it has estimated to kill about 627,000 people in 2020, and there is a spatial concentration of those deaths. So in terms of cases, 95% of them are found in the African region, but more importantly, 96% of those deaths are happening in that African region. The example I'm going to be using is Ethiopia. It's got quite a significant amount of deaths, 70,000 annually, and the population is about 114 million, but 2/3 of that population are at risk from getting malaria. This malaria isn't spread out evenly across the country, as we know that geography is important, and so we can see that there is an uneven distribution. In the Central Highlands, we get an area which is malaria free, and we'll look at the causes of that later. The Western Lowlands is where we get the highest transmission, and in Eastern Ethiopia, which is a mix of lowlands but also desert regions, we get very low transmission rates. In terms of the highest risk areas, the regions known as Gambela, Tigray, and the western areas of Amhara, they get the highest rates of transmission and the highest prevalence of malaria, and the transmission rates get particularly high and peak in this area after the rainy season. So the rainy season is June to September, that's the main rainy season, and we get really high cases after that. The opposite end, we get really low transmission rates in Afar and Somali. This is a very arid, desert-like area, very high temperatures and little rain, and therefore we get low transmission rates in this area. I'm now going to look at the environmental causes that have led to that pattern. The most obvious thing that kind of probably comes out from that pattern already is that mosquitoes, they love warm, wet tropical conditions to be able to grow. So we can see here is a pool of stagnant water that's been left behind, and the larvae have been able to breed in there and then will soon become mosquitoes. So anywhere where we get these big pools of stagnant water after a long period of heavy rain will be perfect for mosquitoes. And we can see that if we look at the annual temperature and precipitation for Ethiopia, in this area on the west, we have got high temperatures consistently, so above 25, 26 degrees all year round, some up to 35, and similarly, really high precipitation rates, so lots of areas above 2,000 millimetres in a year. So that where we've got higher temperatures and high rainfall in that western lowland region, this is where malaria is endemic. It has been there historically in the population for many generations. Obviously the opposite is happening in the Central Highlands, and the main reason that we have very little rates in the highlands is because of altitude. What we know happens as we go up in altitude is that temperature decreases. You might have noticed this when you walk up a hill yourself. You start off, it's quite warm at the bottom, and then by the time you get to the top of the mountain, it's very cool. This happens pretty much in all areas of the lower atmosphere, and it happens here in malaria. So the Central Highlands, as we go up in altitude, the temperatures get lower. Malaria don't like this. They find it very hard to breed in those cold conditions, and so because there's such a lot of mountains and high altitude in that central area of Ethiopia, we get it malaria free. I put some other facts in there that might be of use. If it's below 10 degrees, malaria can't breed or function at all, and if it's below 15, they're very lethargic. So we need that optimum temperature of somewhere north of 24 to 28 degrees for malaria to be able to thrive and breed in high numbers. Now looking at human causes, the first thing to notice is in this kind of western region, we've seen an increase in rice cultivation. So here we can see they flooded fields to be able to actually grow rice, but also they're implementing irrigation schemes in areas like Gambella. Essentially what this has done is, because it's provided more surface water, this means there is more potential breeding sites of mosquitoes, because we could potentially get stagnant water appearing. So by creating new patterns of surface water, we're increasing the chance of mosquitoes and malaria therefore occurring in that western region. Similarly, in the same region, I've highlighted here, they've built a large dam in western Ethiopia called the Grand Ethiopian Renaissance Dam. It's just in that area north of the Gambella region. But by creating a large dam, we have a huge reservoir created behind it, and this actually creates an environment for stagnant water and therefore mosquitoes, which can lead to malaria rising in the local area. They've seen quite a close link between dams being built and increased malaria cases soon after. And it's not necessarily that the fact it's just a reservoir, but it also that on the shoreline it creates little pools of water that doesn't really move much, and that's where we get lots of the mosquitoes breeding. Another big human factor is the fact we get lots of the population migrating to go and work in agriculture in those western lowlands. They move from the malaria-free central highlands, where there's very low rates of malaria, to these western regions, and they seem to move in very big numbers during the time when it's the rainy season. So they're going there to be part of harvesting often, and that's happening at the same time it's in the rainy season, so we get optimum conditions for peak malaria transmission. Lots of rain, lots of high temperatures, and then suddenly a huge influx of people from which malaria can spread from person to person via those mosquito vectors. One other factor that increases this even more is that agricultural workers often are likely to get infected because they sleep in the fields during that harvesting period, and the mosquitoes are more active after sunset, and it's after sunset that sometimes harvesting is occurring, and when then people go to sleep, they've got more exposure to be getting bitten by mosquitoes during night. And as you can see here, very few of these people have mosquito nets, so they don't have any protection from being bitten. One other kind of key area that's slightly different to what we talked about so far is Ethiopia is a developing country, and as it can starts to urbanize and have bigger urban populations, we get new breeding sites in those urban areas. So garbage dumps are a prime location for mosquitoes to breed in. Also discarded containers. So if there's like water buckets outside people's houses, we get more of these as there are more people, and therefore there's more sites for mosquitoes to breed in. The last thing to mention is that we have found drugs that are able to tackle malaria, but as we've continued to use them, the malaria parasites and the mosquitoes are becoming more resistant to them. So an example is chloroquine. It used to be used in Ethiopia to tackle malaria and still is used to an extent, but it's become less effective. And so that means if we got drugs that are less effective, that means sometimes people are still catching them because we haven't had any major malarial breakthroughs in the last 20, 30, 40 years, even though there is a vaccine being proposed at the moment which could change that for the future. But because these drugs don't work as well, that means more people are likely to get it.